Looking for a 3D printing technology to create strong, functional parts for demanding applications? 9 out of 10 engineers will most likely recommend selective laser sintering, or SLS 3D printing. Low cost per part, high productivity, and established materials make SLS 3D printing ideal for a range of applications, from rapid prototyping to low volume or custom manufacturing of in-use parts. In this video, we'll show you how selective laser sintering works, the different materials available on the market, its various applications, and how you can get started. SLS 3D printers use a high-powered laser to fuse small particles of thermoplastic powder together to create solid parts. Since the unfused powder supports the parts during printing, there's no need for dedicated support structures. This makes SLS ideal for complex geometries including interior features, undercuts, thin walls, and negative features. The self-supporting nature of the technology also allows operators to tightly arrange multiple parts within a single build to optimize material usage and maximum throughput. Once the build chamber cools down, printed parts are removed, separated, and cleaned of excess powder, which can then be recycled to reduce or even completely eliminate waste. SLS 3D prints have a naturally grainy finish, but can be further post-processed by media blasting, tumbling, painting, or coating to achieve the desired finish and material properties. SLS 3D printing materials offer excellent mechanical characteristics that resemble traditional injection molded parts. The most common SLS 3D printing material is nylon, a popular engineering thermoplastic that is lightweight, strong, and flexible as well as stable against impact, chemicals, heat, UV light, water, and dirt. SLS nylon is a great substitute for common injection molded plastics, as it can be sintered in parts with superior snap fits and mechanical joints compared to parts made with any other additive manufacturing technologies. It's ideal for functional applications requiring long-lasting plastic parts, where parts produced with other 3D printing processes would degrade and become brittle over time. Nylon 12 is the most commonly used SLS 3D printing material. Equipped with high strength and environmental stability, it's ideal for functional prototypes as well as durable in-use parts and complex assemblies. Nylon 11 is a higher performance alternative that offers higher elasticity, elongation at break, and impact resistance, but lower stiffness. Nylon can also be reinforced with other materials to boost its performance, such as glass for rigidity or carbon fiber for lightweight and strength. Beyond nylon, SLS printers can also create flexible TPU parts with unmatched design freedom and ease. TPU is an elastomeric material balancing high elongation at break and superior tear strength that is ideal for producing functional prototypes and in-use parts. Laser sintering TPU provides a great alternative to traditional molding workflows and a superior solution to other 3D printing methods for producing tough and long-lasting flexible parts. SLS 3D printing accelerates production and innovation across a wide range of applications in the engineering, manufacturing, and healthcare industries. It empowers engineers and designers to take control of the entire product development process from concept to completion using rapid prototyping, functional prototyping, and the manufacturing of ready-to-use products. It empowers manufacturers to take control of their own supply chains and respond quickly to changing demands. Manufacturing applications include low-volume, stopgap and bridge manufacturing, mass customized consumer products, as well as replacement, aftermarket, and spare parts. For manufacturers that change their product designs frequently or only require a limited series of parts to be made at once, SLS 3D printing is often a more viable and affordable alternative to traditional manufacturing processes that require tooling. On top of that, you can also use SLS 3D printing to improve the efficiency of manufacturing processes by quickly producing custom aids, jigs, fixtures, tooling, and replacement parts right on the factory floor. In healthcare, SLS 3D printing is used to create ready-to-use, patient-specific models and medical devices, including anatomical models and surgical guides, long-lasting prosthetics and orthotics, and other biocompatible in-use parts. Selective laser sintering has been one of the most popular 3D printing technologies for professionals for decades, but the complexity, requirements, and high price of SLS printers have limited its use to service bureaus and large enterprises. Ordering parts from service bureaus is still the preferred choice for anyone who just needs a few parts occasionally, but cost and lead times quickly add up, chipping away at the benefits of why you would choose SLS 3D printing in the first place. Recent advances in machinery, materials, and software have made SLS printing accessible to a wider range of businesses. Benchtop industrial SLS 3D printers like the Fuse series from Formlabs offer high quality, a compact footprint, and streamlined workflow at a fraction of the cost of traditional industrial SLS systems. Bringing SLS 3D printing in-house is easier today than ever before. Can you think of an example of how you could use it to improve, expand, or diversify your business? Subscribe to our channel for more 3D printing content and visit the links in the description below to explore Formlabs 3D printers and our range of over 40 advanced 3D printing materials.